Welcome to my third presentation that delves into vortex mathematics from the very different angle. I have started in my first YouTube presenting to you exploration of new shapes which are based what I started calling hexagene and hexanons, and creating the basic structures which created our truncated tetrahedrons and truncated octahedrons in a very specific proportions. What came out from exploring clusters which were able to be built using those puzzle blocks was very obvious that it had tendency to start building another enclosed three-dimensional shapes. The one I will be concentrating on today is our cuboctahedron and anti-cuboctahedron, which are very compatible spaced in time when we rotate octas and tetras together, but with a little bit of additional pieces, I discovered they build clusters on their own. So that's what we're gonna explore today. I'll just remind, or for someone that has not watched the first material, this is one of the models that we've used, which has basic setup of three tetras at the bottom, one in the center, and three octas. So I've got 4 sets of the same pattern, and I am able to place one on top of another, and by doing so, we enclosing the space. If you can imagine that our truncated octas and tetras would have the window enclosed, well, the sphere in size will also be enclosed. So the idea started when I looked at the paper cutouts of cubo-octa, but just in 2 parts, and the model was basically showing the twist that just happens naturally. So there is a natural compatibility of those 2 shapes to itself. So this one was creating our anti-cubo when we've got 2 windows of octa lining up next to one another. However, we can turn it into cuboctahedron from anti by just creating a rotation. So the beginning here would have our cubocta. If I add the centers together, they also encapsulate our shapes. So if we put the 2 together, we can rotate it from the center as well as on its sides. This model is a little bit too big in the center, but I think you get an idea. And this is another model which was pointing in the direction that, again, we're gonna look at just in a moment. We can create our cubo-octas. They'll be here at the top, or we can fill in the gaps with anti-cubocta, which what's happening at the pattern, instead of our triangles facing in one direction, anti-cubocta changes the direction by 180 degrees. So it's this flip of the triangle at the top and the bottom. So let's see what we can do with those shapes. To start off, we're gonna have a look at the most basic models, which consist of either cuboctahedrons mixed with anti-cuboctahedrons and anti-cuboctahedrons on their own. And I have created the 6 basic models that can interact with its own doubles, which we'll go into in a moment, but also have got capacity to interact with one another. What is quite peculiar in those models, and I'll just show them from the different directions, that we have 2 ways in which the models will come and into an assembly. So one way is, that's our triangles in the center, with the triangles radiating out. And our blue blocks in this section are all cuboctahedrons. Our red ones are anti-cuboctas. So what's happening here? We've got this space which is asking for a feeding. As you can see, they do come together. In this scenario, we've got 7 cuboctas with anti-cubocta at the top, and it creates the pattern of, if you can look at this section, almost like an arrow pointing up when we examined the top part, and when we look from the bottom, we've got half of our pyramid, which is the very normal pattern of cuboctahedra on its own. What's also interesting about the patterns that I will be demonstrating to you now is that the inner center in each cluster will have octahedron on its own in a miniature form, encapsulated, just like we discovered cubocta and anti-cubocta. This time the primary force that we'll find in all of those models and in different configurations will be octahedron itself. So let's look at how the models would work. We've connected those 2, and if you look at it from the side, they create quite a beautiful pattern, and you can see the triangulation of energy. Those 2 also close up, and we've got the reverse, where we've got anti-cuboctas, which is 7 of them, and cubocta at the top. And this pattern has got like a flower pattern starting from the top, which radiates out in all directions, and from the bottom we've got the full flower opening. So that's another connecting the 2. With this model, as you can see, there is our triangles on the edges, so there is no way I can lock them this way, but what fits is if we turn it upside down and adjust it from the bottom or from the top. Now this one is kind of fixed in its own interactive force. These 2 guys can be flipped over, and by doing so we're creating another pattern. This time we've got like a waveform from the top coming down in all directions, and when I flip it upside down, we've got our flower opening on 3 sides. So in this case we've mixed, the top is total anti-cuboctahedron, this is 3 cubocta, 1 anti. When we look at this model again now, actually it would be good to look them side by side from this way, because this way we've got the arrows kind of pointing down. When you look at this model, they go sideways, so the arrangement is transformed once again. When I flip it upside down, we've got this directional arrow pointing down, but not up. So this is again cubocta, 3 anti with 1 cubocta. So the models have got quite a number of connections. I'll show you a few more possibilities. That was my original models, which I've only initially discovered 4 possibilities to start with. However, with more printed pieces, I was able to explore the subject a bit further. So what we've got, our full 8 cuboctahedrons create cube-like pattern, which has got truncation on a corner, and each side will have half a pyramid or half of the octahedron. If I'll split it open for you, in the middle you will see that it would contain octahedron, that's top and that's our bottom. And each of those models does the same thing. So that's one way of connecting the cube. I'll show you one more, which was quite interesting. Instead of having 2 flat surfaces joined together, I've had 2 models which were the same thing, but just connected in a different way. So we've got 2 models split in a different fashion. Now if we look at this one, that's when we were getting indication using our anti-cuboctahedrons. We've got this flower-like pattern on each side that it's fully open. So this pattern is quite pretty and very balanced in its own symmetries. Again, the patterns look the best if placed on a little corner, because then the symmetry shows up a little bit better. Our next pattern is different again to the ones up here. We've got the arrows, which are the same on all sides, but if you look from top to bottom, they'll be rotated by 180 degrees. So each end wall is rotated, which again indicates the spins of energy. There is one more pattern which is quite interesting to look at. We've got the arrows here pointing up. If I look at from this side in all 3 directions, but if we look down, it's the same pattern repeated again. So it's got its own unique force and again contains octahedron in the very center. And the last pattern, which is a little bit different from the previous ones because it's got a little bit of oddity, but this oddity seemed to make sense. So let's examine our top and bottom, which is again this boat-like shape or arrow shape, would be this time lined up. And if I keep rotating it, we've got this funny face, cat-like face, or you can imagine, which repeats itself on all sides, but only within the center perimeter. So the top and bottom are different, and this section is quite unique. It does work as well. We're gonna look at another type of configurations using the same original models. This time, however, I've made a double of each one, which is at the back row. And what we're gonna look at is, instead of assembling them into cube-like configurations, sitting them on a triangular faces, with our top and bottom. So as you can see, we're getting a different setup with this mini cluster, and what would fit inside of it this time, instead of our single octa, if I place our miniature here at the bottom and one on this end, you will see that we're getting a double octa now that's concealed in the center. What will make this cluster grow is additional pieces of our anti-cubocta, which, if I'll just add one for you, now you'll have a look how it all starts locking in together and concealing double open octahedron at the very center if we put two more anti-octa on the remaining sides. So that's one way of configuration. There is another way with this cluster, which a similar situation is happening. We can add our anti-cuboctas on the corners and encapsulate double octa in the center. So we've got those two that look very similar. Manage for them to stay for me. Rotate it towards you. The third one again can line up, which again the space in the center gets filled in with two of them. Going into the next model, the similar scenario is happening. However, we have to use different piece because this one does not contain octa. This one will fit in either pure octahedron like this, and then we can close it together, which changes the topography again. Or I can put in our anti-cubocta, which changes the pattern. It rotates the top and bottom by 60 degrees. So we're locking in our double octas, or alternatively we can fit in additional missing cuboctas or octas. That's one more pattern with double octa in the center, and the last one will have cubocta or anti-cubocta locking it in. So if I move them maybe to the side, those two patterns grow this way. And those have got double octahedron concealed. We will learn what it means with our open octas, because they will be stretched out in time, or we can build it into just about indefinite lengths. So let's move the models for a moment on the side, and I'll give you one more example of joining cuboctas and anti-cuboctas in this little example where I've got only two pieces in the center and three on the sides. In this example, anti-cubocta in red, cubocta at the top. In this one, it's purely anti-cubocta. and the last sample has got 2 cuboctahs in the center and 3 anti-cuboctahs surrounding it. So the color here is a little bit different, but these are again the most simple shapes that could be derived using the two pieces together. So to look at more clusters, let's have a look how building from anti-cubocta on its own would look like. So here the one in the center could be either kept in or removed to create our channels. So this model would be compatible with it. Now we've got in this scenario in white our cuboctahs surrounded by anti-cubocta to lock it together. And the difference between the two is the rotation of our anti-cuboctahs. In this scenario they will connect to another piece just from the sides. In this one we can incorporate our cuboctahs or anti-cuboctahs, but they will be locking it from the edges. And the other two combinations include our cubocta in white at the very ends with anti joining it together, and the opposite here when I place cubocta in the very center and we've got anti-cubocta surrounding it. I've got a little marks here to show you how it will grow when we start connecting more cuboctas on the sides. So if I can just bring them in to the spots. So we will be creating another layer. I've got a couple of more to go. And almost there. But you can see how the pattern is quite pretty and it unfolds one more time. There is a similarity between the patterns. This one we've got purely in the center cuboctas. This one had only one of them. But if you look from the outside, they look very much like similar pieces. The difference is if you look closer at the top connection, this one's got an arrow pointing up, this one is enclosing itself in. So there is a slight variation when we take it to the next level. When I took anti-cubocta and kept adding pieces that would fit to all the sides, we ended up with this model. So this is extended version of that. The same topography or very similar would be created if we work on this model, which again's got the same proportion of walls to build on. However, the top and bottom's got cuboctas, so the top and bottom will have different properties just in our geometry pattern here. We are expanding our models step by step. This one has originated from this configuration where I placed 3 cuboctas in white in the center and surrounded it by anti-cubo. Adding another layer of cubocta, this time in blue, created this pattern, which has a beginning of the channels in 3 directions going up. they could be closed, and that's what I've done on the other side of it by just adjusting few more pieces. So if I let go of the top section, you will see that the space was actually enclosed now. So I'm able to fit into the space our double open octa. So one will sit at the bottom. If I place one here at the top, this section will actually close it in for us. So I can do the same process from each side, and that will be the spacing of double open octa in 3 directions from the top and 3 directions from the bottom. One way of looking at this model would be this one, which is just representing the internal guts of it. So we have cubocta in the center and 3 channels going up and the other 3 channels going down. As you can see, they are rotated as well. There is another possibility using a very similar pattern, but this time I've changed it slightly by placing, instead of our 3 cuboctas in the center, I've got anti-cubocta at the top and at the bottom. The difference here is that instead of having our double open octa, which are already here concealed, I have got room to add one more piece, and if I do so, then the whole thing will be closed. And again, I can repeat it from all 6 directions, 3 at the top and 3 at the bottom. So the inner guts of it will would be extended by an extra level on both ends. And the last variation that we can again add to this pattern would be this piece, and that will allow us for a channel, instead of being locked in, to be extended, and we can choose the size of extension by the number of rings that we join in. But just to give you an indication that we are growing that central column, and again it could be done from all sides. To join the 2 pieces together, we have the room for anti-cubocta to go around and lock it in fully. So this is 2 different possibilities with this cluster and double octa from this one. There is one more piece that conceals double octa. If we go into the simple shape, there is room and filled from both sides, so locking it in, we're getting again triangular pattern unfolding from both ends. If I go a next level up on this model, we arrived in with this one and another ring of octa in blue, cubocta in blue on the edges. This time again our double octa is concealed in the very center, but we can also find it, if I take this piece again, on the outer walls. So if we build it up and around, they will be located in the center as well as on 6 sides. So double octa concealment is definitely happening. Another way of perceiving the patterns and the channel could be this miniature. This time I'm dealing with anti-cubocta in yellow, both top and bottom, and as you can see, when I join them in, they originate a pattern of 3 channels running alongside. Now, taking this pattern into the next level, we'll come up with this formula, which again has got 2 options. One would be to have the central channel completely with anti-cubocta, and another one with the top and bottom piece having cubocta fitted in. What it will change is capacity of how we will build the channels whenever we'll start closing them in or extending them further. So to give you one more demonstration of how we can extend it up, I'll just grab a couple of pieces of anti-cubocta. So as you can see, they will be just lining up here on the edges. Oopsie. Now that's better. This combination once again gives us a possibility to close it off. So if I hold it for you, we have closed one channel from one end. We can do the same from both ends and to each channel as well. So taking them apart, and here again, if you look, we've got central channels that would look like this. It is open octa, which twists or rotates around itself, and with our 3 channels in the center, the next level of channel orientation will be happening here. We've got room to add on another channel in this direction, and we can basically go around the model and expand it from each direction sideways as well as top and bottom. And another model that we can examine to see the channel formation, this one in a singular fashion, would be this one. It's built purely of anti-cuboctas, all the rings just being layered one on top of another. And again, on this model I can explain one more time the capacity of closing the channels. So I can use our cubocta this time from top and from the bottom, and that's our enclosed pattern of 1, 2, 3, 4 open octas. However, I can go into our anti-cubocta as well, just change the rotation of it a bit, and that also would close the pattern. So if I use 2 of them, we're changing it to look like that. Again, you can see that on the edges the green pattern fits in. So we've got one in the center, but they could also be grown now 6 of them along the edges. If I keep rotating, that's what the pattern would look like. So there is one more way of connecting and blocking our cuboctas with joining them to go into the circular fashion. I've created one more model. This one, however, is different. I've got a ring of cubocta running at the top and bottom in blue, and anti-cubocta going around to join it together. And in this model you can see pentagon in the top and at the bottom. However, when we took a mold from the center, it looks like that. So I've got one ring of cubocta and a ring of anti-cubocta, which changes the pattern. When we look at it from the side, there is another mini octa that would slot in on the outside. So I've got this pattern happening at the very core, but also radiating out from the walls as well. When I was trying to build on this cluster, what seemed compatible was this arrangement to lock it in. So if we kept going on our sides, there is another 4 or 8 of them that could be extended. That's one pattern that I can perceive, at least at this moment. So let's put it back up. In this section I will demonstrate for you energy properties of this piece, which's got cubocta ring, anti-cubocta in white, and cubocta ring. What I have been determining originally was whenever there is a difference in spin between our octa ring and anti-cubocta, and it seems to be the case. But let's start from seeing what the energy coming from the center does. So when I position the pendulum close to the center and at the lower part of the arrangements, the pendulum will go into clockwise spin. And as I move my hand up gradually, it's like the force of energy is amplifying. And if I keep my hand moving upwards gradually, the pendulum will get its full momentum. So it will take a moment, but if I get it into the right height, it will go almost there, into very fast spin, which is almost hard to control. So there is something unusual. I haven't found such a strong force on any of the models, and it seemed to be happening at a certain height with this strength. If I'll relax it and go into the lower level, we will stay closer to the parameters. It does not seem to have the full momentum that we witnessed. To look at it from sides, there is push and pull, so energy is radiating down as well. If I lower it to the middle section, oops, it's a little bit high, but you can see that there is definitely an energy drag. So there is a current running in clockwise and anti-clockwise direction, but also through the very center. And what it looks like straight line. I have been measuring the energy currents using the pendulum and established that the top vortex is clockwise, the middle one anti-clockwise, and the bottom one clockwise again. Because the pendulum cannot be placed on a side to determine the spin, I did a couple of things. One was to establish a clockwise spin on a bottom ring, on a top ring, and when the diameters just is past the walls, just lower it down to where I reach the energy grid of anti-cubocta, and within moments the pendulum will start collapsing, so the vortex is not happening in a clockwise position. However, if I induce it manually to go in anti-clockwise direction, it will continue run very smoothly. It's very happy to be stable. To reverse the procedure, I have done both ways, either through lowering the pendulum and the vortex will collapse at the bottom, or by raising it higher and again it will collapse at the top. So let's see if the spin is happily going anti-clockwise. I'll just lift it up a fraction and the pendulum is not happy. It starts to collapse and the vortex is running in the opposite direction. There is a different configuration and not as strong when I look into this one, when we've got anti-cuboctas in white and in blue. Again, we've got 3 rings and a space in the center is open. The vortex measured on this piece is not as strong, but still, let's see what happens. So it is a clockwise vortex, and it will encompass itself. So if I lower it down, it's not collapsing like it did in this model. So that's when we could create what I called a tube made out of our open octas, and that's how the energy current measures. Again, it's quite strong. If I get my handle in the center and a little bit above it, the momentum is quite potent. So they both throw up clockwise circuits. I'll have to break it down. And on sides, if I place it towards you, again it will be going in and out. And this is quite a strong push. So this is probably quite simple way of determining the flow of energy in the models, but that's the beginning and that's the indication what's happening on the inside. I was presenting this combination last time and I said that we've got a minor degree lacking to close it to become an enclosed pentacle. We've checked it with Ian's help on a computer. The degree is actually very small, and maybe it is still a way of building things. With this model, I was able to get the net files, and as you can see, geometry is a little bit off on the edges. Some lines are a little bit thicker than others, but the degree of closeness, it's quite amazing. there is few other clusters that I will be adding on to the files that the link will be left at the end of the YouTube. Different rotations of different clusters that we've looked at up to this stage. So we've got 6 octa and 3 anti-octa from 2 different perspectives. Another pair would be, when we used it was 21 anti-cuboctas. We were creating this model. So here you've got pure perfection. There is no maladjustments of degrees or angles. And that's just another example with 9 anti and you can see triangulations, triangles and squares, how beautifully they work in space as well. And this is unfinished sphere which I was attempting to create using cuboctahedrons. However, because the degree of angles was affecting each face, I've run out to too much difficulty and the model was just not holding the way I was expecting it to. So it is unfinished version. If anyone would like to attempt it, that's a little bit of a warning. Thanks to additional pieces that I've collected, I was able to derive 2 more topographies. One consists of cubocta in the center with 8 channels or 8 octas radiating out, and the other one consists of again cubocta in the center, this time with 6 octas closed in and a top and bottom one open. To get into those models, we had to work around, in this instance, with our cuboctas, placing it on each end and arriving at the grid of 9 by 9. There is 2 ways of closing in the corners. At this end I completed it with cubocta, just like the rest of the pattern. However, the other corners in blue have our anti-cubocta added. So if I turn it upside down, this end has got also anti-cubocta, so you can see how beautifully it triangulates. And the side pattern would be like this. If you look at the side pattern of cubocta at the bottom and anti-cubocta, we've got this profile. I've started in the same fashion in the second model, but kept going around in a slightly modified version. Again, in the center I have cuboctahedron, in red cuboctahedron surrounding it. But in this model I can close our sides with cubocta and just fill it all around. But with top and bottom, as this model is indicating, I can add our anti-cubocta ring and, determining the length, choose how long the central channel would be. So this could be done from top end as well as from the bottom end. So yet one more variation of spacing our octahedrons in time. And the last pattern, which has got one more variation, and I will show you how we can close it in. It has anti-cuboctahedron in the center in yellow I've surrounded it in red with cuboctahedron, blue anti-cubo and white anti-cubo. So we've got this now space unfilled from two sides, which our cubo-octa will close in. So we extended it one more size into closed channels radiating from all directions. With this model I can also add on to this piece, so you can see how anti-cubocta can fit in with cubocta at the top. So this pattern could be locked in and a distribution extended further. On one end I've locked it in with anti-cubocta. On the other end I've reversed here from cubocta to anti, giving me one more possibility of extending the channel. So this end could be grown again. So we've got open end on one side, closed double octa from the top. Sorry, that was our closed octa from the top, and double octas on the sides. So I don't have the pattern for this variation, but you can see how versatile is this geometry, and I'm sure there is a number of possibilities that I had not chance to explore yet, and it is a matter of time and getting more materials 3D printed, which I'm forever grateful to Ian for coming up with more and more products for me to utilize and turning my cardboard ideas into more proper models, which makes life easier to present and photograph for the gallery section. This time I've placed our cubocta in the center and connected cuboctas to it, but not using our square walls, but our triangles. This model, however, seems limited on its own because I cannot fit anything in the center, either cubocta or anti-cubocta. The spaces are too widely open and there are gaps in each direction. So I would call this cluster its finished version. There is a last section which I would like to present and conclude with, and we will be looking at energy grids that I have created inside our cuboctahedrons and anti-cuboctahedrons. So let's start from our cuboctahedron, which has got 4 planes crossing one another, and the 3 pictures, one next to another, will show different angles and perspective of the same cluster. So 2D expression as opposed to 3D expression is very different. This model has been expanded, so to take it into the next level, when we've connected 4 cuboctas, again 3 different planes of rotation and the grids that line up into the and the last configuration that we'll look at is adding 8 of them, so we doubling each time. And this time I've realized what an amazing pattern I got created, especially this one where we've got outline with in the center Star of David, but also if we look from the sides we've got them on 6 sides as well. So it's a good indication of fractality. So looking at it from 2D perspective, it would be hard to imagine what the 3D model would look like. So the 3D model that we, where the models came from is this one, where we, if I set it up, we've got 3 triangle at the top, triangle at the bottom, our 4, 4, 4, and 3, 3, 3. So our cuboctahedron grid. And just by rotating it and changing the angles, that's how I was able to get those pictures. And everything I looked at in the last YouTube was to spinning the models. I still haven't found anyone that could help to create our animation program to capture what's happening in the grids, but I'll just give it one spin here to give you a little bit of indication what I'm looking forward in the future. So depending from which angle we look at, we've got circles in the center, we've got the vortices going on the sides, and the whole picture is indicating that there is a lot of energy currents happening on the inside. One way to spin it is from just one end, another way to spin it would be from the top triangle, so spinning it in this fashion, which would create another energy imprint. Just behind me there is few models from original shapes where I was connecting tetrahedrons and octahedrons in truncated forms and then looking what sort of grid they would create. And the difference between my models and the standard models on all of them is that there is a gap created between the tetra and octa. So they are slightly separated, yet the connective lines lock in the whole structure. So if it's expanded in time, it's getting a few cobwebs. Every part of it is interconnected. And again, they could be spun, maybe not as fast, but if I keep spinning it, we're getting circles instead of our hexagons or triangles. So it would be really good to explore the aspect of span geometry, as it might give us a lot of clues. And another model which most people are familiar with, Star of David in 3D. Again, my model has got degree of separation between internal octahedron and external tetrahedrons. So it does connect in the fashion that joins all the points from octa and tetra into one grid. Just try and spin it a little bit. Okay. So it's not as clear in the daytime as it is in the nighttime, but from the inside I can see almost like a two tear shapes, formations, one from the center reaching to the top tetra, and again one from the center reaching to the bottom one. So there is few more discoveries to be made and few more models to look at when they are spun properly, to see how everything holds and also what kind of vortices are generated. There is one more picture in a series which is derived from our anti-cuboctahedron paths, which initially I thought would be appropriate, and we get 3 takes from different angles, creating 2D pictures that look like this. So that's corresponding to this pattern. Again, it may be the appropriate model or it's still debatable, and I'll explain to you in a moment why. One more correction I need to make: I keep referring to it as netfab files. They are STL files, and netfab is the program that allows you to view it and rotate it, so you can take a look and the picture from whichever angle you choose. They also would assist you with 3D printing. The reason I'm not so sure which is the most correct mode for our paths of cubocta is that having the models connected in this fashion, which was referring to our cubocta paths, because as on paper model I was explaining, we can take it into 2 halves and rotate them, and that's what's happening in those models. One is having our anti-cubocta, which's got 4 and 4, 3 and 3. So our triangular and square bases, if we look at our original models, and a triangular top and a triangular bottom. So that would be the possible model of our anti-cubocta, replacing this one. This is our cubocta when we're rotating our squares and triangles. So they look very similar. The big difference here is if you look at the circles going on the outer edges, our cubocta is very harmonized. In anti-cubocta, we starting to develop only one circle running through the center, but our sides will kind of slant into the side. So it changes our topography. They are both worth exploring further, as the subject has not been explored fully, especially our anti-cuboctas. It's still uncharted territories. It would help to have programs or a means to test the grids and geometry much more properly in the future. One more thing which I've acknowledged, a lot of people have made reference of my work and discoveries into Buckminster's Fuller's work. I obtained one of his books called A Fuller Explanation, which I didn't have the chance to read fully, but just glancing through it, it points that direction of our tetrahedrons, octahedrons, and definitely cuboctahedrons. It's so important to comprehend fully and to understand the fullest capacity of its expression. So I hope this will contribute to the new journey of discoveries. For me, it happens in incremental steps. When I get more pieces 3D printed, I'm able to do more assemblies and explore the subject. So in this presentation I may not have covered all the possibilities, but hopefully created a groundwork, what goes with what and how we can expand on the geometry. So I've started with 2 shapes and ended up with close to 20 models. There should be a few more models if we add more pieces to expand them. It's been a very interesting exploration, and I would hope that other people will get inspired and this geometry will be tested further and maybe we'll find proper applications for it. I would like to thank you again to Darcy for his ongoing help, and he will be cleaning up this presentation and helping to put a new photo gallery with those shapes on the net, as well as additional files that you also could view if you download NetFab. They can be rotated and 3D printed or 2D printed if you choose for your own needs. My great thank you also goes to Ian for 3D printing more pieces for me and doing all the work creating the NetFabs so they will be available. With recording this time our assistance comes from Sandy Regan, so thank you very much for recording this material. I'm looking forward to the next presentation where hopefully there will be more material added. If anyone wants to follow this work or to get more information what is already available, at the end of this YouTube there will be the link to all the photo galleries, NetFabs, as well as all the free YouTubes. So thank you very much for your attention, and I look forward to the next time. I also would love any feedback if someone would like to take this work on board and explore it further. Thank you.